Diamonds have long been considered a source of wealth due to their rarity, marketing, and commonplace usage in high-end jewelry. As a result, miners and local businessmen have looked far and wide for rock deposits which contain these highly pressurized carbon gemstones. One such highly rare rock type which diamonds are typically found within is known as kimberlite. Unlike the vast majority of other types of lava, as kimberlite can be both intrusive and extrusive, it is not mainly composed of silica or silicon dioxide. Whereas, for example, rhyolite generally has more than 69% by weight silica, kimberlite tends to have less than 30% silica. As a result, kimberlite, much like comatite and carbonatite, does not fit on a typical TAS diagram. Diamond-bearing kimberlites generally form in areas of the planet which have a section of stable crust which has remained largely unaltered for more than 500 million years. Over this time, elemental carbon deep in the crust undergoes significant heat and pressure, which converts it to another form of carbon, diamond. A carbon dioxide and gas-rich intrusion might then eventually occur, sending molten rock towards the surface at speeds close to 70 miles or 112 kilometers per hour. Along the way, the kimberlite magma might intrude into an area with diamonds in a craton, carrying with it some of the diamonds as it moves upwards in the crust. Eventually, this magma reaches the surface and a highly explosive eruption occurs, depositing diamonds on the surface and at depth below the newly created volcanic crater. To understand just how rare kimberlite is, let me put it into context. Until very recently, only a single kimberlite pipe had been found and dated to originating within the last 30 million years, an approximately 25 million-year-old several-mile-wide pipe which does not contain any diamonds in Buell Park, Arizona. This is why it was all the more surprising when a far younger kimberlite deposit was discovered in Tanzania. This deposit formed just before the end of the last ice age and encompasses what is known as the Igwisi Hills volcanic complex. The Igwisi volcano is located in west-central Tanzania, where it is 102 kilometers west of the city of Tabora. This volcano is located in surprisingly close proximity to one of the main sections of the East African Rift Zone, where the crust is spreading apart to the east and west, and this is quite important. Although the exact reason why this occurs is unclear, kimberlites seem to be generated in a surprising abundance during certain large-scale breakups of a continent such as Pangaea. Although the young kimberlite deposit here is seemingly an isolated occurrence, its existence suggests that more similar features might form in the future. The Igwisi Hills volcano consists of three closely spaced features known as tuff cones. They formed when repeated explosive eruptions over a short duration built up ash around an active crater, forming a low prominence feature which might look like a cinder cone but is not one. This ash and pyroclastic material has largely buried sections of the original active craters, which in the case of the northeast cone was initially 370 meters or 1,214 feet wide. It is unclear whether the three tuff cones formed at the same time or erupted as three separate events. However, due to their occurrence along the northeast line of activity, it suggests that an underlying fault line or fissure helped define the site of the three eruptions. While the exact date of when these cones formed is unclear, we are pretty sure when the northernmost cone formed, 10,450 BCE during the human Stone Age. This volcanic complex is quite weird because the expected volume material at distance is not present to suggest a highly explosive eruption like would be expected from a kimberlite pipe. After the mildly explosive eruption or eruptions ended at this complex, it produced three low-viscosity but short-distance lava flows. Sadly, none of these kimberlites contain any diamonds. As a final note, I want to add that some scientists do not consider the rock which erupted at Igwisi Hills to be kimberlite. The composition of the supposed kimberlites at this volcano are slightly different than traditional kimberlites. Thanks for watching. If you would like to request a specific topic, please leave a comment below. Additionally, I would like to thank Michael Straw for supporting this channel.